At 12,800 feet above sea level, on a windswept plateau in the Bolivian Andes where the air is thin and the sky is a shade of blue you almost never see at lower altitudes, there is a collection of shattered stone that does not behave the way ancient ruins are supposed to behave. Most ruins, when you look at them, make a kind of sense. You can see the stonework and imagine, even without expertise, how it was done. You can feel the human logic behind it. Rough-hewn blocks, mortared joints, the visible effort of hands working with available tools toward a comprehensible goal. Puma Punku does not do this. Puma Punku looks like something that fell from an engineering catalog for a civilization that does not exist in any history book. And the closer modern technology gets to it, the more precisely the scanners map its surfaces, the deeper the electron microscopes look into its molecular structure, the more carefully the 3D modeling software reconstructs its original form, the stranger and more demanding the questions it raises become. This is not a story about aliens. The alien theory is, to put it plainly, the least interesting explanation available for what happened at Puma Punku, and one that the actual evidence does not support. The real story, the one that peer-reviewed science has been assembling piece by piece through scanning electron microscopy and X-ray diffraction and photogrammetric survey in materials. Chemistry is far more extraordinary than anything ancient astronaut theorists have proposed. Because what the science is revealing is not the work of beings who came from somewhere else. It is the work of human beings who understood their materials at a chemical level, who had mastered stoneworking techniques of breathtaking precision, and who built a monument of such extraordinary quality that, 15 centuries after its construction, engineers examining it with the most advanced tools available are still working to fully understand how it was done. Puma Punku, whose name means Gate of the Puma in the Aymara language of the Andean highlands, is not a standalone site. It is part of the larger Tiwanaku complex in western Bolivia, located near the southern shore of Lake Titicaca, the highest navigable lake in the world, sitting at over 3,800 meters above sea level. The Tiwanaku civilization, which built this site, was one of the great pre-Columbian cultures of South America. At its height, between roughly AD 500 and AD 1000, Tiwanaku was the dominant power across a vast region, encompassing parts of what are now Bolivia, Peru, and Chile. It controlled agricultural land through some of the most sophisticated, raised field farming systems ever devised in the ancient Americas. It maintained trade networks that reached from the Pacific coast to the Amazon basin. At its peak, the city of Tiwanaku itself is estimated to have supported a population of up to 400,000 people, a metropolis by the standards of any civilization on Earth at that time. And at the ceremonial heart of all of this, at the edge of the city where the sacred architecture was most concentrated, stood Puma Punku. Carbon dating of the earliest construction phase at Puma Punku, taken from organic material found at the site's foundational layers, gives a calibrated date range of roughly AD 536 to AD 600. This places it firmly within the Tiwanaku cultural period, at the beginning of the civilization's great florescence. The site was not built over a single season, or even a single generation. It was a sustained construction project, modified and expanded over centuries, representing the accumulated architectural ambition of a civilization at the height of its powers. The Spanish chronicler Pedro de Cieza de León, the first European to document the site in 1549, wrote that the stones were so perfectly worked and the joins so precise that it was impossible to believe human hands alone had made them. He asked the local Inca people who had built it. They told him it had been built in a single night by the god Viracocha before the rising of the sun. They had their own explanation for what seemed inexplicable. The 21st century has better tools for finding the truth. The first thing you notice about Puma Punku, looking at photographs, is the H-blocks. They are not the largest stones on the site. That distinction belongs to the great sandstone terraces, the largest of which weighs somewhere between 130 and 180 tons. But the H-blocks are the most technically arresting. They are made of gray andesite, a volcanic rock, and they stand roughly 1 meter high. Each one is shaped in the profile of an H when viewed from the end, 2 upright sections connected by a crossbar, with precisely cut channels running along the interfaces. What makes them remarkable? What makes engineers and stoneworkers who look at them carefully go quiet and then start asking questions is the precision of their geometry. The faces are flat, not approximately flat. Flat to a degree that implies measurement and grinding of extraordinary consistency. The angles at the junctions between faces are right angles, not close to right angles, verifiable with a precision instrument. In the interior corners, the recessed channels and the interlocking slots that run along the interfaces of the H profile are cut with a consistency across multiple separate blocks that implies either a single template being applied with extraordinary accuracy or some form of manufacturing process that goes far beyond what simple stone hammers and chisels can explain. For a long time, The primary tool available to researchers studying these blocks was careful measurement. Archaeologist Alexei Vranich of the University of California, Berkeley, spent years at the site excavating, measuring, and analyzing the scattered remains of what was once a complete ceremonial building. Because Puma Punku was systematically looted during the colonial period, its stones repurposed for other construction projects, its contents stripped, its standing architecture demolished, none of the approximately 150 large blocks that originally constituted the building are in their original positions. Vranich's contribution was to use those measurements, along with historical data, to attempt a reconstruction of the original building. The first major digital reconstruction effort used photogrammetry, overlapping photographs processed by software to produce precise three-dimensional models, alongside laser scanning and measured hand modeling to capture the exact dimensions of every surviving fragment. The result, published in the journal Heritage Science in 2018, was the first serious attempt to answer a question that had been asked since the colonial period. What did Puma Punku actually look like? The reconstruction revealed something remarkable. When the scattered fragments were digitally reassembled in the way a jigsaw puzzle is assembled, matching edges, matching slot profiles, matching channel dimensions, a building began to emerge. Not a vague outline, but a specific structure. A platform building with multiple doorways, some full-size, some miniature replicas of the full-size versions, arranged in a sequence of threshold spaces that researchers have interpreted as a deliberately designed processional architecture. The doorways were aligned in a way that would have created a sequence of increasingly restricted access, moving from a large public space through progressively smaller and more exclusive thresholds toward an inner sanctum. It was, Vranich concluded, a building designed around the experience of movement and enclosure, a piece of architecture in the full, sophisticated sense of that word. But the reconstruction also made the precision problem more acute, not less. Because when you fit those pieces back together digitally and look at how they were designed to interlock, you see something that the individual fragments do not make clear. The H blocks were designed to slot together into larger structural assemblies, with the channels on their interfaces serving as guides that would lock adjacent blocks, together without mortar. The tolerance required for this interlocking system to work, for the channels on one block to accept the corresponding projections on the next without gaps, without rocking, without the misalignment that would produce structural instability, is very tight. The blocks were made to fit each other. They were, in a precise technical sense, prefabricated components. The word prefabrication implies standardization, and standardization in stonework implies a system of measurement. The Tiwanaku builders clearly had such a system. The recurring dimensions across the H blocks, the consistent channel widths, the consistent slot depths, the consistent angles, all point to the application of standard measurements that would have been defined in advance and applied across the production of multiple blocks. This is not guesswork. It is what the 3D scans show when you overlay the digital models of multiple H blocks and compare their dimensions. The consistency is not accidental. It is the result of a systematic approach to manufacture. How was the manufacture achieved? And this is the question that has generated the most heat, and where modern materials science has produced its most surprising and genuinely significant results. The conventional archaeological explanation that the Tiwanaku craftspeople shaped these blocks using stone tools, specifically hammerstones and abrasives, combined with copper chisels, and patient grinding, is supported by actual physical evidence. Quarry sites in the region show the marks of stone hammers used to extract and rough out the blocks. Unfinished blocks at Puma Punku itself show the progressive stages of working. Initial shaping by pounding, followed by progressively finer abrasion with sand and flat stones to achieve smooth surfaces, and then final finishing to the precise geometry of the completed form. Experimental archaeology, the practice of actually trying to replicate ancient techniques, has demonstrated that andesite, while genuinely hard, can be worked to tight tolerances using these methods. It requires patience, accumulated skill, and systematic application of technique. It does not require diamond saws or laser cutters, but there is a complication. And it is a complication introduced not by fringe theorists, but by peer-reviewed materials science published in leading journals. Beginning with studies conducted between 2015 and 2018, and published in journals including Ceramics International and the Journal of Construction and Building Materials, Joseph Davidovits of the Geopolymer Institute in France, working with colleagues from the Universidad Católica San Pablo in Peru, subjected samples from both the sandstone megalithic terraces and the andesite H-block structures at Puma Punku to scanning electron microscopy, energy dispersive X-ray spectroscopy, X-ray diffraction, and thin section petrographic analysis. The results were unexpected and have been, to say the least, highly contested. The sandstone megalithic blocks, the largest stones on the site, the ones weighing up to 180 tons, showed a chemical signature that Davidovits and his co-authors argued was inconsistent with naturally formed sandstone. Specifically, the blocks showed elevated sodium and iron content compared to 3 geological sandstone samples taken from sites in the surrounding region, including from the Calamarca geological formation, which is identified as the source of the sandstone raw material. The thin section microscopy showed what the researchers described as a thick, fluidal red ferrosilicate matrix between the sand grains, a feature they characterize as very unusual in geologically formed sandstone. Their interpretation, the massive sandstone blocks at Puma Punku, are not quarried stone. They are geopolymer concrete, a form of ancient synthetic stone made by mixing processed sandstone aggregate with an alkaline binder derived from natron, a naturally occurring sodium salt found in Laguna Cachi in the Bolivian Altiplano, cast in molds and allowed to harden. The Tiwanaku builders, on this interpretation, were not stone carvers, they were concrete chemists. The implications of this, if confirmed, are extraordinary. Geopolymer concrete, a type of inorganic polymer formed by reacting aluminosilicate materials with an alkaline solution, is a genuine and well-understood modern material. It is more durable and more environmentally sustainable than Portland cement, and there is significant modern research interest in developing it for construction applications. The idea that an ancient culture independently discovered and applied the basic chemistry of geopolymer formation 14 centuries ago would be a finding of major scientific significance. The smaller andesite H blocks produced an equally startling result from the same team's analysis. The scanning electron microscopy of the andesite showed the presence of organic matter, specifically carbon and nitrogen, in the stone matrix. Organic matter is, as Davidovits put it in the published paper, very unusual if not impossible in a solid volcanic stone. The interpretation was that the andesite H blocks were also made from artificial stone, not cast from a liquid slurry as the sandstone blocks appear to have been, but formed from an organomineral precursor material shaped in molds and fired or cured to produce a hard, stone-like product. This interpretation is not universally accepted, and it is important to say so clearly. The mainstream of Andean archaeology and material science has pushed back, arguing that the chemical anomalies Davidovits and his colleagues identified can be explained by geological variability, by post-depositional chemical alteration of the stone, or by contamination during the sampling process. The debate is genuinely scientific. It involves disagreements about methodology, about the selection and representativeness of comparison samples, and about the interpretation of chemical data that admits more than one reading. It is not resolved. But the existence of the debate, the fact that peer-reviewed studies have found chemical signatures in these stones that require explanation, is itself significant. The blocks are not just visually puzzling. Their internal chemistry is being actively disputed by serious researchers in serious journals. What the 3D scanning and digital reconstruction work has contributed to this debate is a more precise understanding of what would actually be required to produce the H blocks by any method. When the interior geometry of a typical H block is digitally modeled and the angles and dimensions are measured at high resolution, what you find is that the interior corners, the recesses where one flat face meets another at 90 degrees, are not rounded, they are sharp. Not the chamfered edges you get from abrasive grinding, which inevitably rounds the intersection between two surfaces, but geometrically precise right-angle intersections. Sharp interior corners are genuinely difficult to produce by grinding and abrasion. You can grind a flat face. You can grind two flat faces that meet at 90 degrees, but the point where they meet will, in abrasive work, always tend toward a radius rather than a true corner. To achieve truly sharp interior corners in stone by conventional methods requires either chiseling, which leaves marks, or a manufacturing process that forms the corners in a mold, where the corner is defined by the mold geometry rather than produced by removing material. The IDIA Lab reconstruction project at Ball State University, which used laser scanning, photogrammetry, and advanced 3D modeling techniques to create their digital model of the Puma Punku complex, found that the precision of the block geometry, when digitally analyzed across multiple surviving examples, is remarkably consistent. The slot widths, the channel depths, the interior angles, these vary within a range that is narrow enough to strongly suggest either a standardized template system applied with extraordinary skill, or a manufacturing process that inherently produced consistent geometry. And here is where the technology is genuinely illuminating something that centuries of looking at the surface could not reveal. The interior surfaces of the H blocks, when scanned at high resolution, show surface textures that have been interpreted by different researchers as consistent with either very fine abrasive finishing of cut stone, or with the surface characteristics of cast material. Smooth, where the mold face was smooth, slightly irregular, where gases escaped during curing. The two interpretations are not easy to distinguish without destructive analysis of the stone's internal structure. What is not in dispute is what the blocks accomplished architecturally. The digital reconstruction of Puma Punku, built from the precise dimensions of every surviving fragment, shows a building that was, by any standard of ancient construction, extraordinarily sophisticated. The processional doorway sequence, the interlocking block system, the precise alignment of the entire platform to compass bearings. These are the products of careful planning, systematic measurement, and execution of very high quality. The site was built at 12,800 feet above sea level, in a climate of extreme temperature variation, using materials whose sources were kilometers away across terrain, that demanded either organized land transport or, given Lake Titicaca's proximity, water transport across the high-altitude lake. The logistics alone, quite apart from the stoneworking, represent a major feat of organizational complexity. And this is perhaps the most important corrective that modern science offers to the fringe narratives about Puma Punku. The alien intervention theory, at its core, is a theory about human inadequacy, a claim that the people of the Tiwanaku civilization could not have done this, that the gap between the assumed capabilities of an ancient Andean culture and the evident quality of the site is so large that extraterrestrial assistance is the only available explanation. What the archaeology, the materials science, the 3D reconstruction, and the experimental archaeology collectively show is that this gap is a product of underestimation, not of genuine impossibility. The Tiwanaku civilization maintained a city of 400,000 people in the high Andes. It practiced sophisticated raised field agriculture on a scale that transformed the landscape. It maintained trade networks spanning hundreds of kilometers. It produced ceramic and textile art of extraordinary quality. It had, in short, the social complexity, the accumulated technical knowledge, and the organized labor capacity to build exactly what it built at Puma Punku. The stones are not impossible. They are the product of a stoneworking tradition that had been developing for centuries, applied by craftspeople at the peak of their civilization's powers to materials they understood well, whether that understanding was expressed through grinding and abrasion or through something more chemically sophisticated that the science is still working to fully characterize. The precision is real. The mystery is real. But the mystery is a specific technical one about exactly which methods produced those sharp interior corners, those flat surfaces, those precisely standardized slot dimensions, not a cosmic one about whether human beings were capable of it. Puma Punku was looted and destroyed during the colonial period. Most of what the Tiwanaku builders created is gone, repurposed into churches and farm walls. What remains is a scatter of extraordinary fragments lying on the high altiplano, slowly being mapped and analyzed and chemically interrogated by researchers who are still a decade and more into serious modern scientific engagement with the site, finding things that require explanation. The electron microscope keeps finding organic matter where volcanic stone should contain none. The 3D scanner keeps finding interior angles that abrasive methods struggle to fully account for. The chemical comparison between the blocks and the quarry sites keeps producing anomalies that the conventional geological model cannot cleanly absorb. None of this means aliens. It means a civilization we have systematically underestimated, working with materials and techniques whose full sophistication we are only now beginning to appreciate. The H-blocks of Puma Punku are not a mystery from beyond this world. They are a mystery from within it, from the high Andean plateau, from a culture that flourished for 5 centuries and built something in stone so precisely made that 1,500 years later, when our best machines finally look inside it, they find things that still do not have a complete explanation. That is not a sign of extraterrestrial intervention. It is a sign of the extraordinary depth of human ingenuity, working in a place and a time and with a knowledge base that we are still, despite all our technology, only beginning to understand.